Welcome, everybody, to this month's Blatchford webinar. This is one we're super excited about. We finally get to share the good news about our latest product called the Avior. I think you'll find after this webinar, you'll see why we're excited about it. This is something that's truly going to change the lives of K2 patients. So without further ado, I'm going to go ahead and get started. But before we truly begin, everybody is on mute. And if you've been part of these webinars in the past, you know this is how we always run them. So everybody's on mute. There is a Q&A panel that you can ask questions for. And myself will either be watching for those Q&A questions, or Chad O'Connor will be watching for those questions and answering as we go forward. And if it's something that we need to interrupt the person who's speaking for, we'll happily do that. You can register for future webinars at blatchfordmobility.com/webinars, and you can view all of our previous videos and webinars on our YouTube channel at Blatchford Institute /featured. That's got all of our previous webinars, and as you know, we do these every single month on, we try to aim for the third Thursday of the month at 2 o'clock Eastern. So that's why we're here today. If you have any questions, feel free to reach out. My name is Mike Magee, and you can email me at mike.magee@blatchfordus.com. So as I said, my name is Mike Magee. That's my QR code. You can feel free to scan that. That's got my contact information. You can have it. It's got my cell phone, so you can always text me any kind of questions. And it has an opportunity for you to share your contact back with me, so feel free to do that. Like I said, we're really excited about this product. It's something we've been developing, and I've gotten to be part of some of the testing that we do for it, and it's just a lot of fun. Somebody's saying they're not getting audio. If anybody else is having any problems with audio, please let me know. I think it's going through. I'm not on mute, so that's the good news. Chad, if you want to come on and introduce yourself, and then I can see if I can hear you.
Hi, Mike. Yeah, my name is Chad O'Connor, a regional clinical specialist for Blatchford. Been in the field for about 20 years now, and I'm really excited about this project as well. Like Mike said, I've gotten to see some of the early testing of it as well, and it's been really fun to work with. So,
thanks, Chad. And I've been with Blatchford for 13 and a half years. Private practice prior to that. I'm a CPO. And let's go ahead and let me see if I can still control your screen here and get going. So what is Avior? Avior is our K2 microprocessor knee, and it's truly a knee that was designed from the ground up, and you'll see why as we go throughout this presentation. It was truly designed for the K2 ambulator. There's all kinds of things that we're going to talk about that really benefit that patient profile more than any other patient profile. They all benefit, but the K2 especially. So that's why this was created, and that's what it does. So who is the Avior for? What are the indications that we're looking for? We're really looking for a K2 individual, and as most of the people on this call understand what K2 means, but there's a wide spectrum of K2, and what we're really looking for in this is somebody who is a true K2, low activity, K2 to maybe low activity K3. It does get up to about 2.5 miles an hour, so it does get fairly fast, but it's truly designed for a new or a K2 patient. And think like your brand new amputees, brand new transfemoral amputee patients that need something that's going to be truly very supportive for them. That's what this patient, that's what we're looking for. The max weight on it is 125 kilos, which is 275 pounds. We're not looking for those high K3 or K4 patients, clearly. It is truly designed for the K2 patient. Now, if you do have a patient that you're kind of unsure what to do with it, whether it's is it a K3 or a K2, or they're probably going to progress up to a K3 or a high K3, within a fairly short amount of time, then of course we've got our Orion or our Lynx, which are indicated for K2 as well. But this one is designed specifically for that low-level patient to really get them up to the next level. That's what we're trying to do, is help these individuals get from this low K2 level up to a low K3, and then eventually progress into a higher K3. That's what we're trying to do. It's not currently for bilaterals. Will that be changing? I'm sure it will be, but as of today, it's not set for bilateral usage. So, let me try clicking again. Why did we develop this? I think clinicians as a whole would agree, and we've said this for many, many years, that microprocessors are really beneficial for the K2 individuals. So that's something that I think I would get very little pushback from the CPOs on this call. We know that microprocessor control and hydraulic control is really important. Being able to use the need to ride it down into a chair, stumble recovery, all that kind of stuff is really beneficial. We're going to help reduce long-term medical costs, of course, but we know that that's the patient profile. We've always known that, but now with the new LCD updates, we have the ability in the US to be able to bill for that. So again, it's a very, very timely launch, but we're really going to be able to help these patients that have been underserved historically. So, Chad, if you can press the next button, it's not clicking for me anymore. It was working just fine. So let's talk about the traditional K2 knees just briefly. I know we all know what they are, but as you know, with a mechanical knee, they did some things really good. Some of them were pretty safe. You know, a manual locking knee, the patient knew exactly what was going to happen. They knew it was safe. They'd have to pull up a lever to allow to be able to sit, and then they couldn't ride the resistance down into the chair, but they knew it was stiff and they wanted it to be stiff. So that part was kind of good, but they couldn't go downstairs, they couldn't sit. And then you had a weight activated knee. And again, that improved upon that. It allowed you to be able to be stiff when you needed to be stiff and free when you needed to swing. But there was no yielding, there was no stumble recovery. You couldn't go down slopes in a controlled manner, and certainly not stairs or sitting down. They were basically had resistance anytime you put weight into them. So this is where that's really going to come into play, is being able to change that up. And the Avior is going to do that. It does all of those things that were the limitations of the previous devices. Now we can fix that. We have microprocessor control of both swing and stance. And we have three base configurations. And why do we call them configurations and not modes? Well, we call them configurations because of how configurable they are. It's not simply a mode. We know that every patient's a little bit different. So being able to configure each one is what's really critical. But let's look at our three base configurations. We have lock, which when you hear these lock free, and all that kind of stuff, think about breaking that up into two parts. The first word is all about the stance control. The second word is all about the swing control. So in lock, we've got locked in stance and locked in swing. Lock free, we have locked in stance and free in swing. And yield free, we have yielding in stance and free in swing. Now, that doesn't mean free like there's no stumble recovery or any of that kind of stuff. No, we've got stumble control. We've got all of that, of course, but we have, but it's allowed to flex in swing phase. That's why we mean free. So it's not free swinging and no resistance. It's got the resistance you need, of course, but we call it free. And they can, of course, the user can sit in all three configurations, even in lock. Patient does a certain motion, which Chad's going to go into, and the patient can sit freely without any problem. We have stance flexion in all configurations, not just in lock free, but we have it in lock free, and technically yield free is yielding, so it's a little bit different, but lock and lock free without any problems. And again, here's our configurable settings, and that's a picture of the app, the screen there. We have lock, we have lock free, and yield free. So lock, and that's kind of the progression you would allow your patients to go through. With lock, those are for your patients who need maximum stability. You want the benefit of a manual locking knee, if you will, but you also want to be able to sit down. So that's what the lock is good for, brand new patients. and then eventually progress them up to lock free to where it's more of a weight activated knee. When they put weight on it, it's locked. And then when they start trying to move, it gets free and is able to move easier. Yield free is a little bit more like a typical microprocessor knee. So the idea is that's the progression you're going to progress your patients through as they develop throughout their rehab. And with all three of these base configurations, we can set up stance flexion, like I said, in 0, 5, or 10 degrees of knee flexion. Now, one really important concept to this is this biomimetic design. We have the ability to have a polycentric knee. So you can see when the knee flexes, that instantaneous center rotation is going to move from an anterior position down to a more distal and posterior. And that's going to allow the shin or the prosthesis actually to push back on the patient's limb and the chassis to push back on the patient's limb as they sit, keeping a more secure connection onto the limb. Of course, it's going to fold up closer for more of a confined seating area like an airplane. That's going to be easier for them because it's going to fold up a little bit, but it's also going to push back on the limb, making it easier for them. And it's also going to provide a slight extension moment when they're standing because of the way those pivots are designed. So it's also got a really nice reimbursement consideration there that is PDAC approved, and we're going to cover that a little bit later, but there is some reimbursement benefits to that as well, of course. So now what I want to do is kind of turn it over to Chad to go through the functionality of the Avior. And again, this is designed from the ground up for the K2, and you're going to see what that looks like. So Chad, go ahead.
All right. Thank you, Mike. Yeah, so the basics here with the Avior, it is built on those 3 base configurations. And we say configurations because they are configurable. You can adjust and you can fine tune each one of these. The programming itself is very simple and does not take very long. But if wanted or if needed, you can go in after the programming and configure all of these even more. So, for example, you've got the lock free, and yield free. So just like Mike said, the first word in that is stance during your stance phase. The second word is during the swing phase. Within each of these, you have that ability to fine tune. So for example, you can fine tune the stance flexion. Not only can you do 0, 5, or 10, you can adjust the resistance of that stance flexion. And then you can also adjust the stance extension dampening, and you can actually adjust the beginning resistance of that stance extension dampening and the end resistance. So fine tuning how quickly does somebody come out of that stance flexion through mid stance as they're rolling over the foot. You can also adjust the swing extension control. So we have a normal and we have fast. Fast is going to be that really giving that proprioceptive feedback for those patients that are used to a knee that snaps out into full extension very quickly. I'm thinking of those patients that have the single axis kind of weight activated locking knee. They're very accustomed to that knee getting into full extension very fast and almost creating some terminal impact there. We won't have that terminal impact, but we have the fast extension that gives them that proprioceptive feedback, giving them the confidence that it's out there. Then in the normal swing extension control, you have that ability to adjust normal within a certain range. And that just helps to control and create a more natural looking gait without it extending out there too fast. And then standing support, it's going to lock in that fully engaged full extension or in a flex position. And then we have a controlled standing and sitting, and then the dynamic slope and stair descent. Those last two are actually 2 different resistance parameters that you can set. One designated for the sitting and one designated for stairs or slopes. So 2 different things, you can program it. By default, the stair resistance will be set as the sitting, but you can go in there and adjust that. And we'll get into that a little bit more in the details in just a moment. But like I said, it is unique to the Avior about all of the fine tuning that we can do. And then So the settings can be updated as that patient progresses through their mobility rehabilitation goals. So let's talk about each one of these, kind of the what you're going to encounter, what the patients are going to encounter throughout the day, right? Obviously, we want our patients to be up walking. So let's first talk about the parameters for a forward walk. The release parameters are no longer just a toe load. We've got several other parameters that are all built in, creating a very safe and stable platform for our patients to move forward. First of all, you've got the tilt, you have a forward angular velocity, and you have a toe load. And that toe load has to happen within 10 degrees of full extension, meaning if the knee is bent at 20 degrees and you are achieving the toe load, it's not going to release. But it's pretty hard to meet that toe load without it being in close to that full extension anyways. So that's the release parameters there. We have stumble control that is active throughout all phases of the gait cycle. So during the stance phase, swing flexion and swing extension. And then, as we said before, stance flexion can be programmed to 0, 5, or 10 degrees in the lock, and lock free. As I said, or as Mike said before, in yield free, stance flexion is unlimited. So there isn't a set 0, 5, or 10 degrees. That's in that forward walk. And here is a video with the stance flexion. Now here he is walking up a slope, but what that does is that allows having that little bit of stance flexion provides a smooth, more natural, it decreases pressures on the back and hips, but also it is safer going down slopes in a lock configuration. So for example, the other day I was working with somebody that going down a slope, he usually goes down sideways, sidestepping down. With this in the lock, we had a lock-free configuration. So when you put weight on it, it was locked, but we gave him 10 degrees of stance flexion. So when he progressed down a slope, he was able to still go down facing forward, more natural, but that stance flexion gave him that ability to to ride the leg down and give him a little bit of give in order to progress down the slope safely as well as more naturally because he didn't have to turn sideways.
Yep.
I'll also say we had the Avalon underneath that, so we got even added benefit of the hydraulic angle underneath. But go ahead, Mike.
Yeah, I was gonna say, I also elaborate on that a little bit more. I fit a patient who we put her in she's coming out of weight activated knee. We had her in lock free, and we put it in 5 degrees of stance flexion, and we loved it. She loved it, and we thought, well, if she loves 5 degrees, she's gonna love 10 degrees. We put it in 10 degrees. She didn't like it. So being able to adapt from 0 to 5 or 10 really makes a difference. The next patient loved 10 degrees, didn't like 5 as much. So being able to change, not just enable it, but be able to change it from 0, 5, or 10 degrees is really advantageous. And then, as you mentioned, you can change the resistance in there as well to make it easier for those patients to achieve that.
Thank you, Mark. So stance flexion, as we said, it is available in lock, and lock free, and it's already yielding in yield free. So there is that more confidence walking down those slopes, giving them extra security, but also that ability to help clear the toe and less of the what I call a pole vaulting scenario, where when you see somebody walking down even a gradual slope that they and it's in a locked knee, they end up pole vaulting and then they have to circumduct and they could be off balance that way. Having that little bit of stance flexion in there gives them that ability to slightly ride the knee down, but have that hard stop at 10 degrees. And then we have swing extension control. I said earlier we have the normal and the fast. Fast is going to really get that knee out there fast, and it's going to give that proprioceptive feedback. So as we said, this is for the K2 population. So it is for the single speed ambulators, right? But that being said, oftentimes they are used to that knee being out there because in order for their old prosthesis to function safely, they needed it in full extension at heel strike. So that fast setting in the swing extension control allows that proprioceptive feedback and giving them that confidence that it's out there when they're ready to plant their heel on the ground at heel strike. Normal is going to provide that more natural speed, but it provides that less feedback. So more natural, but maybe less feedback. So what's nice is that you could start somebody with that fast speed, giving them that proprioceptive feedback. But as they progress in their rehabilitation and you see them back in the office, you know what? They're walking better, they're more confident, drop it down to normal. Now it's a more natural looking gait because they don't need that proprioceptive feedback as much. So that all of these settings are, as I said, configurable and you can fine tune it, but you can also adjust it later on as they progress. Standing support, like many of our other microprocessor needs that we have, it is available in both full extension as well as in a flexed position. So that provides balance, able for patients to transfer their body weight over to the prosthetic side more. And the reason why we have it in full extension as well as in a flex position is if you're standing on a slope, we want that knee to be nice and stable even on a slope without having to bend the knee to engage standing support. So it will engage when you stop and pause with weight on the prosthesis, it's going to lock. You can fine tune and you can adjust the activation of that standing support. So you can either make it a kind of a normal fast speed to activate, or you can slow it down if you want, if patients feel like they want a little bit more time before it engages. So those are all things that can be adjusted. But throughout the normal programming, as I said, it's very simple and quick where you don't have to go in and do that. But if you want to, or if you need to, you can do that. So controlled sitting. What's great is in the lock, in the lock free, and then of course in yield free, all of those the patient can still sit. So the release parameters for sitting is going to be that heel load, a posterior shank movement, and then an angular velocity deceleration. So that all sounds a lot of words going on right there. But what I've found so far is honestly, when patients don't think about it, it's mimicking a natural body motion for sitting down. So when patients just sit and don't think about all of it, they oftentimes engage all those release parameters. They engage it well because this is mimicked off of the natural human body for sitting. Sometimes we'll use words like nose over toes or things like that, but it's that posterior lean. But then as you go and sit, you lean forward slightly so you don't just fall backwards. And what that does is that does decelerate or slows down that posterior shank movement. And then that tells the knee, all right, we're sitting down. You can adjust the starting and ending resistance. For those of you that have fit the Orion and the Lynx, we have yield rate, and you can adjust that with levels of 1, 2, 3, 4, and that adjusts how quickly and how fast the resistance ramps up. With the Avior, we've taken it to the next level in the fact that you can set the beginning resistance, and then you can also set the ending resistance. So depending on how far away or how far apart those two numbers are, will dictate how much and how quickly the resistance ramps up. So it's great because you can have a lower value for starting, and then as so that helps them start to sit, but then you have a higher value at the end. So it ramps up very quickly and steeper to give that support. One thing I'll say right now, because we're in the sitting part, is because of the polycentric design, we get resistance up to through 110 degrees, meaning somebody going into a deeper chair is going to continue to have that resistance all the way up to 110 degrees. They'll have, and that the resistance will ramp up to roughly 100 degrees, and then it'll level off at that and stay high until it gets to that 110 because of that polycentric design. Then we also have after you're seated, the knee goes into a relaxed position, meaning that you can move the knee, flex and extend it easily without resistance to move it out of the way. I always think of like on an airplane, if you got to move it out of the way, it's you're not fighting the hydraulics to do that. Now, as you come to stand up and the patient starts to stand up, once you get part way up, it begins to give a ratchet support, kind of locking the knee so the patient can help get themselves up. Let's say an example though, somebody's part way up and then they're like, oh, you know what? I actually just want to sit back down. Well, we have the Avior is built with an abort function for sitting, meaning that they're part way up. All they do is hit the same parameters that they had to sit. So heel load, posterior shank, and posterior shank deceleration. They hit those parameters and the knee will lower them back into the chair. So you either can have the ratchet effect to help you support getting up, or if you need to sit back down and you're part way standing, it will lower the patient back into the chair. So dynamic slope and stairs descent. I touched on this a minute ago, that we have the ability to have a separate resistance, separate setting for stairs and slopes. So sometimes maybe somebody wants to sit a little faster, but when they're going downstairs, to give them that extra confidence, we want to have them have a higher resistance. So you have the ability to fine tune and add a higher resistance for stairs. It is built off of the same way as the sitting, as far as you have a starting number and an ending number. And how that works is that starting number, once again, that's that initiation of the knee bending, that beginning part. And then the second number is how high does it ramp up. So where I've seen this really been incredible to watch is somebody walking downstairs I saw with a full with a fixed ankle foot. They were able to have their full foot on the stair, and it engaged and it allowed them that resistance and that support going down. But what was incredible about that was, we all know that with a fixed ankle foot, you're trying to go down the stairs with the whole foot on. You're going to be fighting it, and you're either going to it's going to be really hard to engage and get that knee to bend, right? And especially a polycentric design, it's already very stable. With having that adjustability of that first number, we were able to lower the first number down a little bit, and it allowed that initiation of flexion to be a lot easier and engage and start to flex the knee. And then that second number, we ramped it up, gave them that support, and that gave very controlled progression going down those stairs and that support going down. So that's that fine-tuned capabilities. As I said before, this is all done. The programming all takes care of this, and you don't have to go in and do these. But for somebody that is going to be going downstairs and want to progress that step over step, this is that opportunity where you can adjust and have a separate setting for stairs and slopes. So as I said, stumble control is built through all phases of the gait cycle in the Avior. So we've got it in stumble recovery. Oh, sorry, one second. Should be a video. Here it is. So we've got it in swing flexion, swing extension, and throughout the whole stance phase. So through all phases. This is a very hard thing for patients who are good ambulators to mimic. But our patient model here did a really fantastic job in replicating and showing how stumble recovery engages in a swing flexion moment and swing extension. So we've got that high yield resistance. If a stumble control parameter is hit, it's going to give a high resistance to support, allowing the patient to get their sound side ahead of them. And then wheelchair mode. So we have wheelchair mode allows them to raise the leg between 10 and 45 degrees. They'll get 5 short beeps. That's going to stay locked. keeping it out there. So if they need to move themselves around in a wheelchair, it will stay up out of the way. But if you accidentally knock it into something as you're wheeling around, it's going to actively descend and drop free. So there he hits it against the chair and it drops out of the way. The other way that you exit out of wheelchair mode is you just extend the leg. And that's why the range is 10 to 45 degrees, because you need that little bit to extend. Because once you extend it, then it will drop out of wheelchair mode and flex.
One way to keep in mind, that hitting into something, we're not saying everybody runs into stuff with their wheelchair, but sometimes, a grandchild could run around the corner of the hall while they're starting to wheel through the house, and a grandkid or somebody could hit them. Instead of knocking them in the wheelchair around, it's going to just or tripping the kid, for instance, it's just going to drop it down into knee flexion, so there's no damage to anybody.
All right, and then we have manual lock mode and safety mode. So in manual lock, patients can activate it and it's going to stay locked, and they wouldn't be able to sit in it, or it's going to stay locked until they physically take it back out of the manual lock mode. So it's entered just by 3 short presses on the knee, and then to exit is 1 long press. There's 2 buttons on the back of the knee. You've got the power button, and above that you have the mode button, and the mode button is what they would press for manual lock. Safety mode is going to be if the battery is fully discharged, it's going to just go into a high resistance. So they could still bend it, but it's going to be very high and hard to bend, giving them safety if they run into a situation where they've run out of battery. But I'll get into it in a second. But the battery life is 2 days, so charging it every night, they shouldn't have an issue there. Oh, here it is. Here's the battery. 2 days battery life. Only 5 hours to fully charge. We recommend obviously charging it every night. You do not have to have it turned on to charge. It will charge even with it turned off. It won't show you any lights that it's charging, but it does charge. And it is actually, we have a USB-A magnetic charger. So it's magnetic on the knee side, but then it's a USB-A on the other side. So I've been able to charge a knee in a car, and it's worked really well. In 30, 45 minutes of driving around, it added another bar to the battery level of the knee. So that is 2-day battery life in normal use. And then our water rating is IP65. So meaning that you don't have to worry about getting it wet if you're out fishing, if they're, and it gets splashed on, or they're on a boat or something and it gets splashed on. It's not going to worry about it. It's fine. It can be hosed off, rinsed off. Or let's say if it gets dirty in a situation where, something gets on it, and in order to clean it off, instead of just having to wipe it down, you can actually hose it off and just spray it off. You could hold it under jets of water, and it'll be fine to rinse any corrosive material or anything, things you could rinse it off with. So volume and silent mode, this was actually really interesting. The ability to adjust all these, not just turn off the sound, but you can actually adjust the volume level. You can adjust the vibration level, but you can also adjust the frequency or the tone of the sound. So what's incredible with that is I was in a room where one person had hearing aids, and we adjusted the frequency, and it actually everybody in the room said, "Oh, that sounds great." Like they really enjoyed that sound. It wasn't an obnoxious noise, but it was audible enough to know that that there was either an error or you were switching modes, kind of thing, right? But the person with the hearing aids couldn't hear it because that frequency was out of the range that this person's hearing aids was set for. So you just think about like some of our K2 population, right? They might have hearing aids. So being able to adjust that frequency that will register with their hearing aids, or just in general their hearing, is a very, very beneficial thing, because those those noises are going to happen with any feedback of like a battery level indicator or battery low indicator or changing modes. It's going to give an audible cue. So we want to make sure that our patients can hear those. And then there is the silent mode. So let's say somebody's going into church and they want to make sure that no beeps, because they could activate silent mode by pressing the mode button 2 times, and it's going to go into that silent mode. It's not going to go into, so then it silences everything, and they'll still get some vibration and haptic feedback that way, but it's not going to have the beeps. So it'll be obviously much quieter.
I do want to elaborate on that just real quick. I've been asked in my presentations, well, how much does it beep? Does it beep a lot? No, it doesn't beep hardly at all. It's only when the battery gets low or there's error or something like that. It's not something that people have to worry about it beeping very, very often. But being able to change this again is something that I think just our engineers did a good job of thinking about the patient that this device is serving. So I just kind of wanted to follow up or elaborate on that a little bit more.
Yeah, thank you, Mike. Yeah, that's very, very good points. So polycentric design, you already saw this kind of earlier, but this is overlaid over the femur and tibia. And we really designed this to have a biomimetic design. Blatchford, we've talked about biomimetics for a long time. We talked a lot with our hydraulic ankles. So everything we've created, we're trying to create this biomimetic design. And that's really what we did with this polycentric design, really replicating that polycentric kind of that pivot glide motion of the knee. And it has some very great benefits to our patients. One of them is that posterior shift. When they're seated, it really helps push that socket onto the limb, helping prevent that pull, because we all know a lot of our AK patients, especially in a suction system, they stand up, they have to expel that air, kind of push it back down. This helps keep that prosthesis pushed on, and they have to do less of that when they stand up. Also, they get this, when standing, you get this extension moment. Any anterior force is converted into extension moment. So if I were to play this one more time, you'll see the posterior pivot point. When it comes back up, it's actually above the anterior pivot point. So what that does is any type of anterior force really helps promote a even further extension. So just really helping that knee be very stable in a standing position. So here's kind of some of the features of the design here. We have a reinforced touch pad, or the knee pad, so you can kneel on it. It is removable and replaceable. And as I already said, when seated, that kind of the knee tucks away, and it really is a nice, very nice finish when they're seated. You have the carbon fiber finish, so it's tough but lightweight. So we decided not to paint it because paint chips away. This is keeping it lightweight, but a very durable finish. We only have, for those of you who are familiar with the Orion and the Lynx, those have sliding and rotating pyramids. This one is just a fixed pyramid and one knee. So you don't have a different knee that you would order if you wanted a threaded top. Instead, we have a M36 proximal adapter that you could order to convert it into a threaded top. As I said, you have the easy to locate buttons. You have the mode button and a power button, but that's also how you check the battery level. You would just tap the power button once and it will indicate what your battery level is. We have a nice little charge port cover, and then we have that magnetic charger going into a USB-A charging port. Thought there was more. So there is, yeah, actually that's it. So you can use that USB to plug into a power bank or into a car, and it will still charge the knee. We do recommend, if you are plugging it into an outlet, you would still use it. Use the brick that's provided. So technical overview in numbers. 250, that is actually the number of times a second the sensor data is read and control algorithm runs. So that's a lot. 250 times it's running constantly, taking all the data and then basically putting it against these control algorithms and then deciding on what to do. So that's happening 250 times a second. 41 is the number of events. So that is, I think, to put it simply, when microprocessors first came out, a lot of times it was designed just for, is the patient taking a step or not? And that's kind of the things it was looking for. Now we're looking for things like, okay, is the patient sitting down? Are they taking a side step? Are they going forward? Are they seated, but but they've raised it into wheelchair mode? So those are all the different parameters, the events that it can be looking for or will be looking for 250 times a second. So 250 times a second, it's taking all the sensor data and then comparing it to all these different events, and then deciding what to do based off of that. 176 is actually the number of individual calibration points. This sounds like a lot. It is a lot. And it sounds like, well, that's a lot for us to do as clinicians. Well, we don't have to do any of that as a clinician, or hardly any of it, because this is all done based on the program and the computer does this. But that's how configurable the knee could be. Some of these, for example, the calibration points, one of them could be the sound and the haptic feedback. That's a calibration point. But you don't really have to do anything with that. If you want to, you can fine tune and adjust that if needed. So that's an example of what could be done, but just the possibilities out there. And then lastly is 15. So 15 is the number of sensors. So it is the most sensors we've put in a device. It gives us a lot of data. It also gives us a lot of information on responding to different events and different environmental situations because of all these sensors. So the amount of sensors that it can take, it collects all that data and responds in a appropriate and safe way. We'll get into something called Smart Step here in a second, where we might go into a little bit more on the sensors and what they do. All right, so going into the codes real quick. This is PDAC approved. You'll notice all but one are pretty common codes for microprocessor knee, but instead of the 5828, we have the 5615 L code, and that is for the 4-bar linkage or multi-axial. So as I said, that is a average reimbursement increase as well with that L code. But we created this knee for the biomimetic purposes of creating a more natural, stable, and safe gait. All right, so technical specs, we have the build height is 294 millimeters or 11.5 inches. There is no special pylon or anything that you have to get. It's a standard 30 mil pylon that goes in, but the tube clamp does need to be torqued to 15 Newton meters. And the weight of the unit is 2.9 pounds. We have that max user weight of 275 pounds. Activity level is 1, 2, K1, 2, and then even the low K3. As I think Mike said earlier, this can handle speeds up to 2.5 miles per hour, but it is specifically designed for that single speed ambulators. But it does have that ability to handle a little bit faster speed. We have a knee flexion of 130 degrees. The default is, so it actually comes with flexion stops, and it's actually set with 120 degrees flexion stop in there. Is kind of the default, but you could change it out to 130 degrees, or if you needed for a long limb and the socket's hitting the cylinder, you would change it down to 110 degrees. And they're actually in 5-degree increments for those flexion stops. And then, as I said, the weatherproof, it is IP 6.5, so you can hose it off, spray it off, no worries there. And a 3-year warranty. All right, so let's talk about the sitting. I think we've all agreed that when microprocessor knees first came out, it was a big deal of encouraging and coaching our patients to load both limbs equally. We know that that just takes the stress off the sound side if they can load that prosthetic side more than the sound side. So this graph is just showing that with the Avior compared to a conventional K2, able to load the prosthetic side more equally in comparison to the sound side. So you can walk backwards because there is that IMU in there saying that they're walking backwards. And then even though it was locked, you saw there that they did that posterior shift and it engaged and allowed them to sit. So here's that enhanced yield. So it ramps up as they're sitting and then goes all the way up to that 105, 110 degrees of having that resistance. So really providing them to sit and give support through a deeper chair. I was fitting somebody just the other day that had a fairly tall patient and a shorter residual limb, and the chairs in the office were fairly low, even for a average height person, and this person was even taller. So just watching them sit and having that resistance all the way through that 110 degrees of range before they got down, they basically had resistance all the way down till they got to the chair. Whereas most of the time in that situation, I would always see at 90 degrees, they would kind of plop or drop into the chair. So having that large range of support and having that increased resistance as that knee flexes is very beneficial in that, especially in that situation. So here's this good example that I like to show that here you've got a starting resistance, and you see on the graph that the blue and the red, or the blue and the kind of orange, are two different programs for an Avior, two different knees basically. But both of them were set at the same starting resistance, but then the ending resistance was set differently. So you can see how much the ramp up the resistance changes just by how you set the starting and the ending resistance. So this number here is 0, is not accurate because there's normally going to be a value in there. But for example, it could be 160 to 200, 200 being the ending resistance, 160 being the beginning resistance, and then you can fine tune that and adjust it from there. All right, so here's we did some early testing and had some patients trialing it early on. This was the feedback that we got based off of kind of asking all these questions, how they felt, what they thought of various scenarios, as well as how they felt with it. So based off of all that, everything was high, satisfied, very high, very satisfied. Foot selection. So right now we are recommending the Avior with either our two K2 feet of the Avalon or the Navigator. Works very well having that hydraulic ankle, but that Navigator is a great option for a lightweight, low profile, multi-axial K2 foot. We also have it with the Esprit and the Epirus. So if you have the ability to put a carbon fiber foot underneath, the Esprit and the Epirus are very nice, lightweight, low profile. And then like I said, the Epirus has that multi-axial capability as well. So this is all information that we can get to you through your sales rep. And at this point, I'm going to hand it over to Mike to kind of talk briefly about the Smart Step.
Thanks, Chad. Yeah, we're just going to hit the highlights on what Smart Step is. It's more than just a programming app, although that is one big component of it. I can try to see if I have control here. Let's see. Smart Step is it is our programming app, like I said, but it is also our it's got a whole digital health management platform built into it. So it is how you program, but it's also got some other capabilities. The again, for the clinical team itself, we've got the programming that's going to walk you through in a very easy step-by-step process. As Chad mentioned, there's a lot that this device can do, but they've really made it streamlined into programming, and it walks you through the entire process very easily without much doubt as to what you should be doing. And it's just a handful of steps. And somebody did ask the question, so while I'm talking about Smart Sniff, I'll answer it about how much body weight, the percentage of body weight to release for toe load. And what it's going to be doing during the walking calibration stage, the Smart Step app will will tell you what to do. And when you get to this one portion called walking calibration, what you're going to do is just have the patient walk. And what it does is it takes all the toe loads for each step. It takes toe loads for each step, and then it takes the average of that, 50% of the average of those max toe loads. So it's only a 50% toe load threshold, and it's of all the steps, of the average of all the steps. So it's really quite easy for the patient to achieve that. I think you moved your cursor there. There you go. Okay. So again, the tools that the Smart Step app itself can do, we've got the programming, but then we've also got a thing called gait visualizer, and that's what that picture there is. And what that allows you to do is take a video of the patient, and that syncs the sensor data along with the video. So you can do things like figure out what their toe loads are, how they're moving forward with it. Are they sitting using weight on both legs appropriately? You can do a lot of stuff. You can also do things like request an activity for the user. So maybe the patient, well, one use case scenario I can think of is imagine, I used to live in West Texas where patients drove from long ways away to get to the office. All right, they may drive 2 or 3 hours, or your patient may be in a whole nother state on vacation, and then they call you and say, "Hey, my knee's not working quite right. What do I do?" Well, historically, what did you do? You maybe tried to call a friend or somebody else in that area and see if they could go visit that clinician to try to fix it. But now what you can do is you can say, "Hey, in your app, go to the gait visualizer, make a video, and you can see it." And at that point, you can look at that video and you can look at it. You can send that video to us, a clinical team at Blatchford. My engineering team can even look at it, and they can look at the data and be able to help isolate what the problem is. And then you can say, you know what, Mr. Smith, actually, remember we talked about you've got to put weight into the prosthesis. It looks like you're using something different now. You're not putting the weight through it like you used to be. So maybe take a bigger sound side step, really get weight onto that foot. Or maybe there is a problem and it needs to come in. So it can help be a first, the first kind of troubleshooting method and save your patient a lot of time and save you a lot of time. We can also do things like surveys to make sure the patient is still happy, make sure they're still wearing the prosthesis, make sure there's no issues, and collect outcome data periodically throughout that time without the patient having to come in to do a 6-minute walk test or whatever it may be, or a prosthetic evaluation questionnaire. You can send that to them remotely. They can fill it out. It comes right back to you, and then it goes in the patient's chart. So a lot of remote outcome measures that we're talking about here. So it's more than just a programming app, but of course it does have programming. There's also, it will have physical therapy access to where the physical therapist can do some things giving you, after you give them permission, of course, things like being able to change the patient from lock to lock free because they want to do some gait training. You don't have to decide, do you want them in this mode or that mode? You can put them in lock where they're really safe. But then when they get to physical therapy, when they're in the parallel bars, the physical therapist can switch them over to lock free. And then when they leave therapy, it goes back to lock. So there's a lot of benefits that's going to have for the physical therapy access. Again, that portion is not here yet, but it's coming very, very soon. There's also the patient access. They're going to have access to be able to do things like monitor their activity, how far they've been walking, how much have they been wearing it, and all that kind of stuff. And of course, respond to your activity sessions. That's just a picture of the registration and login screen of the app. You as a clinician can't use this app until you have been certified by our clinical team. So we'll come in, we'll teach a course, we'll certify you with your patient, and teach you how to use it, so you're not out there out on a limb on your own trying to learn a new device. We'll go there step by step with you, make sure it's an easy transition for you. And again, the app has a lot of fine-tuned capability, but in reality, it does a lot of it for you. So that's just showing the capability that is in all the fine-tuned screens. There is going to be physical therapy access support. So we've got a little booklet that you can give to a physical therapist if you work with a physical therapist. So keep that in mind. And then lastly, I just want to summarize with a couple of big things. Some of the things that make this device truly unique. We can do things like, obviously we've got our configural modes, but we have our stance flexion in all those modes. That's a big thing. You can sit and ride the resistance, and the resistance is going to increase as they sit. And remember, it's a different resistance than it is with stairs. So things like we can maybe change the sitting resistance so it's very easy for a user to initiate sitting. We can do that because it doesn't affect the stumble recovery. If we made it really easy to sit and it was only one resistance, then that could also affect stumble recovery. But because we're not doing that, it's not going to affect that. So it allows you to really fine tune it for your patient's needs. Again, putting you in control. We believe that you, the clinician in the room, should have a say on how your patient uses the device more so than our engineering team. So we want you to have the control and be able to adapt it for what your specific patient needs. So that's most of the material. I wanted to go to here. This is a quiz. Make sure you scan that. We'll submit the quiz, or we'll submit the sign-in sheet next week. So while we've got that screen up, I want to go and answer some questions. I saw some more pop in. Somebody asked, is there the possibility to update the knee remotely? Absolutely. That's one of the cool things about it. We can, the clinician can, not the patient, but the clinician can update the device. If we have maybe a new firmware update or something that they need to do, we can over the air send an update, and all they do is log into the knee, and it goes seamlessly into the knee, making it easy for the user to maintain an updated knee. It doesn't have to come back to us. We will be at AOPA. Thank you, Dale. We will be at AOPA. We'll be doing a workshop. So if you're coming to AOPA, Chad will be the one teaching that. Come listen to him talk about it. We'll have a patient there. We're going to be demonstrating it and getting you some hands-on. So we will definitely be at AOPA. The app is available on both Android and iOS, and I'm just answering questions as we go here. Any other questions, feel free to pop them into the Q&A panel. But I want to take some time to, while you're taking the quiz or at least scanning for the quiz, I will send the quiz out in a link in case maybe some people are watching on their phone and they can't get this QR code. I'll be sending this out in a link in an email also, so don't sweat it. If you need a certificate, just reply to myself or Kiki. She's going to be in the email also, and we will get you a certificate or whatever else you need for your specific credentials. No, I did not know there was a typo on the quiz on question 4. Hopefully it's still legible. If so, excuse the typo. Thank you, Elizabeth. Jeremy, what we'll do for videos for the actual Smart Step platform and instructions for how to use that. My dog's barking. Chad, if you want to answer that question. We're referring to the videos and webinars in the Smart Step platform.
Sorry, I couldn't get off mute there. Yeah, as far as the videos, webinars, we will have we'll have some in the future as we roll out more of the Smart Step.
Sorry, I just muted you on accident. But we will have a what we'd probably do, Jeremy. That was my fault, Chad. I was trying to unmute myself and I muted you. What we will do is we won't have a There will be stuff on Blatchford YouTube. We do have our own YouTube channel for Blatchford Institute. We've got all kinds of videos in there about all of our products, but you can certainly look for them in there coming soon. They're not quite available yet. But what we'd really like to do, Jeremy, is come to your office and do a course with you. And we'll teach you all about Smart Step. We'll teach you how it works. We will come and do a trial with your patient and get you certified to be able to use the Smart Step app. Because remember, you can't use the app until you've been certified. So you can download the app, you just can't do anything with it. And all the devices that are coming will be in both Android and iOS. And all the devices, sorry, Smart Step will be on Android and iOS. And eventually our electronic or microprocessor control devices will be on one app, the Smart Step app. Thanks, Julie. Really appreciate it. So, Chad, can you review the 3 things to release the knee?
Yeah, I was just gonna say. So to release the knee from stance to swing, we're looking for a toe load, and that is an average of essentially during the programming calibration part. But it's looking for toe load and a tilt and an angular velocity through and all of that needs to be, the knee needs to be within 10 degrees of full extension.
That's right. And lastly, the CEU numbers. Is there space on the quiz to put the ABC certification number? There's not on the quiz, but there is in the sign-in when you registered. There was a spot for you to put that in there. If for some reason you didn't get it, then I will add my you can reply to my email when I send that out. You can reply to that email with your certification number, and I can make sure it's included in that. But if you registered, there was a spot to do that. So hopefully you've got it in there. All right. Well, I hope you guys are just as excited as we are. We just over the moon on this, and the ones that we've been able to fit. It's so fun to see the life-changing smile on patients' faces when they get to see this. They may be going from a manual locking knee or a mechanical knee, and being able to ride the resistance down into a chair is pretty eye-opening for people. So thanks for spending time with us today and taking time out of your busy day. I really, really appreciate it. And Derek asked quickly, briefly, if stance flexion is available in Lock. Something tells me somebody's taking the quiz. Yes, it is available in Lock. No problem. 0, 5, or 10 degrees. That's the beauty of it. Even in Lock, we have stance flexion. Thank you all. Appreciate your time, and look forward to for next month. We'll be doing another Avior webinar. Thank you.
Thank you.